Hi, welcome to the virtual online presentation for the MSc Physics program. My name's Adam Sweetman, and I'm the coordinator for the MSc Physics program, and I'll be taking you through some of the features and exciting things about this program. So first of all, I wanted to quickly introduce University of Leeds. I'm sure you know some of this already as you're looking, but it's something that I think is worth pointing out. Because the situation with the University of Leeds is that it's a single-site campus on the edge of the city. So this is a slightly unusual situation. A lot of times campus universities, they're quite a long way out of the city. City universities tend to be a bit spread out of the city centre. But here, everything's in one place, but you're literally walking distance out from the city centre. And this is it's a really nice feature. It gives you a place to get away, but also allows you to be connected. Obviously, we're a top 10 UK university, University of the Year in 2017. We're the top university for environmental impact research, which is obviously a big thing at the moment, but also a very large university, over 34,000 students and 8,000 staff. And we're very kind of diverse university. We've got a wide range of students and staff from different countries, students from 150 different countries and staff from almost 100 different countries. So kind of focusing now, talking about the School of Physics. So the School of Physics is housed in the £96 million Bragg building. This is the single largest infrastructure investment the University of Leeds has ever made. It's a really beautiful building. I strongly encourage you to visit if you can, or if you can't, have a look at the website. There's some really nice tours. It's a really beautiful building, really state-of-the-art facilities, both in terms of research and teaching environment. In terms of the research, we do have a very research-active department. 90% of our research activity was rated world-leading or internationally excellent at the last Research Excellence Framework. But we're not, of course, totally focused on teaching. We're also very proud that in the last Teaching Excellence Framework, we got a gold, which is the highest possible rank. So really an excellent department, both in terms of research and teaching. In terms of the programs that we offer, I mean, the one that we're talking about today is the postgraduate master's program. But of course, we also have our undergraduate programs, the BSc and the 4-year integrated masters. And we also do research masters. And of course, there's the PhD programs that we have going on, which are, of course, pure research. So something I wanted to focus on a little bit, spend a bit of time talking about, is the research expertise within our school, because you're coming to do a taught postgraduate degree, which means that you're really going to be focusing on the kind of research expertise within the school. And so we have 6 main research groups within the school. First, we have the astrophysics group, which focuses a lot on star and planetary formation. So this is both observational science, but also modeling of how things like solar systems and stars and black holes and galaxies form and coalesce. So a lot of kind of modeling and observational science. And then coming down to like completely the opposite length scale of the universe, we have those condensed matter group who focus on spintronics. So basically studying magnets, but not only magnets in terms of like how you might be thinking of them, but really focusing down on how atomic scale spins can be used to store information and also transmit information. So really low energy electronics, for example. Another very large group in the school is the nanoscience and biophysics group, which I'm actually part of. So this is obviously the studying very, very small systems. So things like single atoms, single molecules, but also then scaling that up to look at biosystems, so things like proteins and cells, and looking at how the mechanics of those can help us understand how things like drug delivery systems can be improved. Another major group is the soft matter group. So these study polymers, so basically soft matter, polymers and complex fluids. And so, for example, one of the things that they've looked at recently is how can you introduce electronics into like soft wearable devices like contact lenses. So this is like kind of merging together kind of traditional electronics and soft matter physics. It's a really exciting research area. We also have the theory group, which study a range of different topics. They study things like quantum information science, so understanding things like quantum computation, but they also do modeling of complex systems, so things like protein folding and other biological systems. Last but certainly not least, something we're quite proud of in the school is we actually have a research group that focuses on physics education. So this is, doing research into understanding how can we best, teach physics, how can we best impart the physics knowledge that we have to students. And, I think this really highlights not only are we a very research active school, but also there's a very strong focus on making sure our students get the best possible experience. So, what is the MPhys program that you're looking at here? Well, the idea is really with the MPhys is that it's a one-year program, and it's to take your physics learning to the next level and develop your research skills. So we assume that you do have a background in physics, but that you want to develop this in a way that will be more, suited to a kind of research-based environment. So there's a range of optional modules, and we're going to go through them now. You can see all the detail on the website. I'll give you the links at the end of this talk. But I did want to point out that, having just gone through the research groups that we have in the school, that we have the option for focus pathways. So there are certain groups of modules that would perhaps be better linked with a project in the same topic. So, for example, you could do a pathway in quantum condensed matter, bio and soft matter physics, theoretical physics, or we even have quite a lot of modules actually that are applied in terms of looking at physics as applied to medicine. Of course, what we tend to suggest is if you do, a lot of bio and soft matter physics modules, you probably want to do a project in that topic as well. But that's not a requirement. You can take a very general program as well, but it is one of the features of our program. You have a lot of choice. So what is the MPhys module? You basically have 90 credits of research modules, so taken from those pathways, but you then also have a 90 credit year-long research project. So half of your year is a single research project. So you get a selection of projects at the beginning of the year. You select one, you're then assigned a supervisor, and then for the next year, you will be focused on that research project. And this involves both doing things like literature reviews, and then learning the techniques, doing the techniques, writing up your research, presenting your research, having a viva. So this is a really big part of your degree, but we think this is a real strength of our degree as well, because this really gives you the experience to have a chance to work in a real research environment in the physics department. So you can do projects, you can do experimental projects, computational projects, and theoretical projects in any of the research groups that I've talked about. You'll be working alongside active postgraduates, that means PhD students, and also postdoctoral researchers, and of course your research supervisor as well. As I pointed out with the Bragg building, you've got access to world-class experimental and computational facilities, which is all housed within the Bragg building. And we really think this program is an excellent preparation for a career in the scientific field. So, working in a company, doing some kind of scientific research, or of course, a lot of people use it as a springboard to PhD study or further academic work. So I thought I'd just talk a little bit about where our graduates end up, because that's probably something you're kind of interested in. So physics graduates here at the University of Leeds have a very wide range of career paths. Obviously, we have people that go into academia. So, we have people who now work at the University of Leeds or at other major UK universities. And of course, there's also non-academic physics destinations. So things like the National Physics Laboratory with graduates who've gone there, or people who still work in physics, but, slightly to the side. So something like physics publishing, editing journals at the Institute of Physics. But of course, you don't have to go into a physics degree. We also have graduates who go and work for kind of major financial institutes like KPMG or large tech companies like IBM. And then there are ones that, are slightly off to the side. And I think this really shows, how general the skills that you'll learn. Even if you're not planning to go into physics, you're going to learn skills that will be very useful in a wide range of industries. So there's kind of local specialist programming houses, developers, and fabricators, and even things like the Ministry of Justice, which you might think like, how did you do a physics degree and then end up in the Ministry of Justice? But that's where some of our graduates end up. So it certainly doesn't close any doors, and I think it really gives you a very good background if you are interested in going into a kind of physics research background. So what do our students say about studying here? So something that I've noticed since I came here, and I think is really evident if you come and spend any time here, is there's a really good interaction between our students, particularly the research students and the lecturers. There's not this kind of barrier that exists in some places. We constantly get feedback. The lecturers are very enthusiastic. They're always very available. You're going to get a lot of interaction. And there's something, if you get the chance to come visit something like a real open day, hopefully that will come across. So that's the end of the presentation. Of course, there's a lot more information you probably want to know, but I think the best place to find that, if you're looking for program information, please go to this website here. That will give you links to all of the module choices that are currently available and things like that. If you are interested in scholarships, this information is constantly updating. So we have a website where it will give you a list of all of the currently available scholarships. If you're interested in applying and you want to know things about, like, do my current grades, are they good enough to get in, when are deadlines, all that kind of information, please contact this email address, which is the admissions email for the program. Or if you're so inclined, you can also contact us on Twitter. And of course, if you've got any general questions about the program, about the kind of research we do or something, you can contact me, Adam Sweetman, as I'm the main program manager. So thank you very much for attending this virtual presentation, and I hope to see you soon.